Bonnie's PowerPoint, so I don't have to come back down here.
All right, I can start talking now. All right, can we take our seats? All right. I know I promised there'd be a cowbell, but I still can't find it, but we'll find it because it's immensely useful in these situations. But you did a pretty good job coming back from this break. It gets tougher as we go through the process. So now we're going to start talking about specific case studies, and really case studies that are innovative in some way. And this should be interesting stuff. We're going to start with Bonnie Colby, who is an economist at the University of Arizona and someone I've known for at least 30 years. Geez, that's a long time. And I've admired Bonnie's work for many years because she's a doer more than an observer. I mean, she's going to talk about a lot of things of which she's had a direct involvement, starting with the Edwards Aquifer work. So, Bonnie, where did you go, by the way? Oh, there you are. And behind curtain number one, it's Bonnie Colby. So, Bonnie?
Thanks very much, Doug. Great to be here. Great to see so many colleagues from Arizona. I believe the temperature differential between Phoenix and Boulder today is 20 degrees even, at least by sometime this afternoon. And I've very much enjoyed talking about water trading in various aspects at this conference over a number of years, and so it was a pleasure to be asked to think specifically about groundwater trading. And what I'm going to do, I will focus on the case study of the Edwards Aquifer because I think it's really instructive and interesting. And we've had many good talks at this conference by Texans over the year on the Edwards Aquifer, and I'll explain a little bit more why I'm particularly talking about it today. And of course, I want to thank some of the groups that have provided funding for the work I do related to water trading, innovative transaction programs, primarily in the Western United States. So trading groundwater, some of the points I want to instill and hopefully have the opportunity to discuss with you. It's one of the reasons groundwater is so difficult is in general, the impacts are lagged. They slow up slowly after years of certain kinds of pumping patterns, so they're easy to ignore until the crisis hits. And that, of course, relates directly to what we heard about the complexities of groundwater governance just before the break from the director of my water center, Sharon Megdal. Groundwater trading is very important for environmental water programs. Those of you who are active in those programs certainly know this, but I like to emphasize it for the larger group as well. The key role of groundwater, again, because it's relatively easy to ignore until something goes wrong. Accounting for trading not only across uses and locations, but the particular seasonal time lags and relationships between well locations and key surface water sites like springs that house endangered species. Really important to consider in these trading programs. And also, as we heard in the early part of our morning, hydrogeology paradigms evolve. We continue to learn about groundwater. That means trading programs have to adapt if they're going to have hydrologic integrity as we understand more about the aquifer. And the interesting thing about this is until there's conflict, in general, we're not investing a lot of money to gather the kind of data and do the modeling we need to do to understand a particular aquifer's spatial and temporal behavior. So we can expect if we're developing a trading program, we're going to have to adapt it as our understanding of the aquifer changes, and that's challenging. So groundwater trading challenge lagged impacts. Easy to ignore until we reach a tipping point. So I put the word sudden acute impacts in quotes because they're not sudden. They've been slowly building over time. But until wells go dry or we start to see land subsidence that's creating significant costs, such as infrastructure damage, we have in general as a society and even as professionals and water managers, we're not acutely aware and willing to think about what we need to do until these impacts become apparent, and by then there's already significant costs. So we've got the, quote, sudden acute impacts that appear. And then we've got longer-term impacts, very clear from a number of studies around the Western states. that changing groundwater levels affect property values. We see this very obviously in farmland values, but it's also true of other kinds of land uses. As water tables fall, pumping costs and the economic viability of economic activity that use water on those lands changes. So there's important economic implications for property owners of changing groundwater levels. And also higher pumping costs can certainly eventually cause certain economic activities to need to depart from a region. It won't be profitable to grow certain crops anymore or undertake certain other kinds of water using activities. So these impacts build up over time. Sometimes they reach a critical point in what appears to be a sudden way. And this lagged, gradual, accumulating effect means it's hard to take political action. There's always going to be resistance, certainly in the areas where I've worked on groundwater trading programs. The early hurdles were getting caps on groundwater use. If you're a landowner and you've been accustomed to pumping the amount of water that makes financial sense for you to pump for your farming operations, your mining and so on, for somebody to come in and tell you this is what you've got, make do, a lot of political resistance to that naturally. So threats of outside intervention are extremely helpful in getting the groundwater caps, pumping permits in place that you need to have a viable trading program. Certainly Arizona's Groundwater Management Act was a big lesson in that, where it took threats of withholding federal funding for the Central Arizona Project to move our Groundwater Management Act all the way through and become enacted, start to be implemented. You'll also hear that same theme of threats of outside intervention causing a state and in some cases local governments to be willing to take the hard actions necessary. The Edwards Aquifer also gives us a good example of that. Intertemporal trading. We really know how to borrow from aquifers, but do we know how to repay the aquifer? California, of course, and I'm glad we have a speaker who will be talking about the efforts in California to work with groundwater management. We know how to borrow from the aquifers when surface water is short. What are the kinds of complexities in thinking about repaying the aquifers so that we've got some kind of sustainable balance in our uses of groundwater and surface water? Where you repay the aquifer really matters. In Arizona, in our active management systems, our active management areas, in general, you can move well locations with a number of restrictions all through the AMA. So we're treating the AMA spatially as relatively like a giant reservoir, moving well locations without a lot of spatial distinction. That does cause problems in some locations where groundwater wells drop more rapidly for a variety of reasons. So what kind of zones would you want to divide your aquifer in, and what do you allow in terms of taking the water out here, doing your artificial recharge over here? And of course, there's the question of how fast you have to pay the aquifer as well. Do you require that amount that's been taken out to be put back if that's the way you're managing your recharge and recovery system? They're managed lots of different ways. Do you require that to be put back within the year, within a 5-year period over some long time averaging system? All water banks that work with groundwater and aquifer storage have to think about this. And then, of course, the last question, and this is at the very broad level, lots of good examples of details on this, is what amount do you pay back? Do you pay back the same volume of water that was extracted from your groundwater account when it's a wetter surface water year, or maybe you have treated wastewater that the institutions in your area allow you to recharge the aquifer with? Is it a 1-to-1 ratio, or some areas, some regions and jurisdictions have a greater than 1-to-1 ratio where there's a cut for the aquifer to maintain aquifer integrity, have a little extra buffer. So you end up paying the aquifer back a little bit more than you borrowed in these kinds of intertemporal groundwater trading programs. Groundwater is very key to environmental water programs. This is a point that should be obvious, but it certainly wasn't obvious in the early years of in-stream flow water acquisitions. There are now thousands of in-stream water flow water rights around the western United States. This is a wonderful accomplishment in my professional lifetime. Most of them are concentrated in the Pacific Northwest by numbers of rights, but this is a major change over the past several decades. Groundwater pumping forbearance agreements are often really important to supporting the integrity of those in-stream flow water rights. In jurisdictions that have good coordination between groundwater and surface water, these special forbearance agreements aren't necessary, but in some cases, for example, in Arizona, in the Zuni water settlement that involved land in the state of Arizona to protect culturally important wetlands, a groundwater buffer zone was set up to limit new wells and new pumping in that area for the sake of protecting the environmental amenities and cultural resources of that land base of the Zuni Pueblo in Arizona. Timing of pumping forbearance. When do you ask the pumps to be turned down or off if your goal is to improve surface water flows? That, of course, requires some of the sophisticated modeling that we talked about earlier in the day, when you know, okay, it's this many weeks or this many months before the impact of this well ceasing to pump shows up in improved stream flows at the target location. Because of these specialty kind of environmental considerations, at this point in time, it's not really enough to be talking about the ability to buy a pumping permit and transfer it to a new location. We actually want to be able to have a much more fine-tuned type of groundwater trading where we can be very spatially and temporally specific. Changes in pumping that are aimed at aquifer levels or aimed at stream flows or spring flows in a particular season that's vital for endangered species, maybe for recreation purposes. We want to be able to have agreements with groundwater users that are triggered by specific conditions. In other words, they're not reducing their pumping permanently or on a regular annual basis, but on an as-needed basis, because that's really where you're able to get the economic benefits of reducing drought impacts is by specialized, fine-tuned water trading arrangements that aim to protect streams with the various values they provide at specific times. And then a rapid response, either for species needs, water temperature has gotten too high for a fish species, flow levels have gotten too low, or perhaps an urban crisis that requires water to be made available from agricultural groundwater users. Our understanding of aquifers clearly evolves over time, and the trading rules need to adapt. Treating the aquifer as a bathtub was the understanding in many of the early groundwater cases, that well locations didn't matter, so the trading rules could be relatively simple in terms of no trading zones, no ratios between zones. We now know that aquifers have a lot more subtle characteristics in general, and they're often discovered as trading and different patterns of groundwater use shift over time. That's how we are able to observe something about aquifer characteristics along with deliberate monitoring, data gathering, and modeling. So in many of the groundwater trading programs that are seeking to protect spring flows, for instance, or stream flows, there's special ratios of trading. If you want to do a kind of trade that would move pumping closer to the river, you're going to have to buy an amount of water. You're going to have to pay for more water than you're actually going to be able to move from that well location. Of course, there are also often spatial prohibitions in some cases on moving well locations closer to the river. And then there's these interesting seasonal restrictions as well, that because we know it takes X number of weeks for the pumps in this area to affect river flows, you can do trades, but not trades that increase pumping during these months of the year, because this stream's under an interstate compactor. This stream has an endangered species flow requirement. So moving to the Edwards Aquifer, which I'm going to use as a case study to highlight some of the complexities that many, many other groundwater trading programs have encountered as well. So this is a long-running groundwater saga, many stages of learning and adapting, very much still having to learn and adapt in 2018, as it was when I first began working in this area in the early 1990s. And why is an Arizona economics professor talking about Texas? In the late 1980s, I, along with actually many of my other colleagues who work in water-related professions, economics, hydrology, law, were infected by what we would have to call, I would call now, water markets fever. A lot of emphasis on that, a lot of books came out during that period. I had the opportunity to work on the cases listed here. Arizona has had an active groundwater permit trading program within its AMAs for many years. It's a small amount of water relative to the water needs of the state, but it provides a much needed flexibility in those areas of central Arizona. So that was getting underway during this time period. We had our famous water ranches, where different interests would buy agricultural lands far removed from cities and then devise various ways to make that water available for urban needs. Some of those worked out reasonably well, some not. The Nevada Truckee Carson Basin was one I really enjoyed working on during this time period. getting a water market going for water quality and also for fish, endangered fish purposes in that basin in the Reno area, Nevada, and the large agricultural areas also in that area. The New Mexico, Middle Rio Grande, and Gila Basin markets were becoming active during this time. Very important flexibility, very important economic benefits to the state of New Mexico that water is able to be moved around the Albuquerque, Santa Fe broad corridor in the middle of the state through voluntary transactions. And then along with the Edwards Aquifer, the case that was the most conflict-ridden and where we actually needed personal safety protocols for the water trading team members when we were in these areas was the Wind River Bighorn litigation. There was a brief period there when the Shoshone, Arapaho, and Arapaho tribes did water leases with farmers whose water access was threatened by the Supreme Court ruling at this particular time period involving tribal water rights. And their team members always went in groups of 3 or more. We were always in unmarked cars, as we had to be with the Edwards Aquifer. And people hoped that no one would get shot and that maybe something good would happen in terms of water, fruitful water management improvements in the region and water trading. And then at the same time period, very enjoyable to work with legislative committees and other groups in Montana, Washington, Oregon, and Idaho who recognized that in-stream flows were an important part of their state's economy and quality of life for their own citizens, as well as the visitor dollars that they brought in. And so the era began of acquiring senior rights for in-stream flows. So the Edwards Aquifer in Texas, the Texas Hill Country, a very beautiful part of that large and diverse state. Edwards Aquifer has a relatively large population that depends on it. The San Antonio metro area, lots of outlying towns and rural agricultural areas. It's rain and surface water recharge in a limestone formation. You can see a little hint of the geology here in the photograph, highly variable. The aquifer levels move quickly. And when they move, they affect spring flows on which a number of federally listed species depend. They, of course, affect pumping costs for farms, industry, cities, and they affect downstream river flows and water users. So these are enormous springs that actually feed enormous rivers downstream, with many parties with excellent attorneys watching what's happening in the Edwards Aquifer, and are they going to get a grip on groundwater pumping to protect downstream surface water users along with protecting their own interests. Little clue on some, we don't really have warm and fuzzy endangered species here, but nevertheless federally listed back in the relatively early after the Endangered Species Act, so late 1970s, early 1980s, and they depend on spring flows at the 2 major springs that the Edwards Aquifer directly affects. Brief chronology, very brief. So the Endangered Species Declarations, conflict, litigation, proposals to tackle aquifer depletion went on for many decades. And in 1993, after a series of litigation brought about by the Sierra Club and downstream water users, the federal courts ordered Texas to take action to assure adequate stream flows. Just before the court-imposed deadline, Texas legislature passes an act that creates the Edwards Aquifer Authority with the regulatory authority to regulate pumping in the aquifer, to set pumping permit caps, establish a permit system. Legal challenges took another several years before those regulatory powers were upheld and the Edwards Aquifer Authority could get into business, and right away active trading commenced. The early trading, this is the era where I was particularly active working in this basin. The meetings with the agricultural interests were very tense. We always went out in unmarked pickup trucks, no signs of the Edwards Aquifer Authority or any other designation on the truck. And the prices that were paid were far in excess of what you would pay to rent the farmland, or comparing them to what you would earn growing crops. We were paying very high, the program was paying very high prices in those areas. And I have to say that our team, for some reason, chose a hotel across from the Alamo. In the evenings, sometimes I'd go wandering through the beautiful park that surrounds the Alamo and think things could be worse. So when the Edwards Aquifer Authority finally got moving, annual pumping was capped at 450,000 acre feet. That number was revised some years later, upwards, as you might guess. And in response to ag concerns, 50% of the groundwater pumping permit associated with agricultural land could never leave that land. It might be that the purpose of the water on that land changed. They couldn't restrict that always to be agriculture, but 50% of the volume of water had to remain on that land, again, because the agricultural industry were worried about spatial migration of that water use, the large sucking sound they envisioned from San Antonio. The Edwards Aquifer Authority assesses a fee to finance retirement of permits to try to bring the basin to a desired balance point. The fees are on per unit volume of water in your pumping permit. The ag fees are 20% at most of the rate that are charged the municipal users. So agriculture, you can see, is very active in negotiating the trading rules and the arrangements and setup. As would be expected, this is one of Texas's most active and productive agricultural regions. In addition to overseeing groundwater pumping, doing monitoring and enforcement, the authority also oversees groundwater recharge and recovery, issues permits for that recovery, and being able to recharge and store water under this recharge recovery system has been very important to the urban interests. The early water trading was started in 1997. They were able to reduce irrigated acreage by 10,000 acres. It was an extremely dry period. The springs were right there where they were violating spring flows set by federal courts. And farmers were reluctant to participate, but nobody needed a calculator to see this is a really good deal. I'm going to earn 4 to 5 more per unit of water than I would have earned growing crops. And I'll go do something else this production season. The ag interest, however, along with accepting the money, certainly also pursued litigation to restrict the authority of the regulatory agency in this case, and also legislation at the Texas to state level to continue to curtail the opportunity for transactions. So it's an interesting case of clear, high payments, but that doesn't remove the obstacles and the efforts on the behalf of a lot of parties to make it more difficult to conduct transactions that move water out of agriculture. So over the years, a lot has evolved in this basin, and I will bring us up to 2018. In 2007, the Texas legislature, conferring with the various interests in this region of Texas, passed legislation that took things a different direction. It raised the cap on groundwater pumping by about 20% from the 450,000, about 20% higher. So all of a sudden, a lot more parties could have groundwater permits, and they switched to an emphasis on dry year reductions. And they authorized some new endangered species measures, and they also were able to make more improvements in agricultural technologies that genuinely reduced consumptive use in some cases, continued to pay for a permanent retirement of some agricultural pumping, and very aggressive urban water conservation programs. In the San Antonio area, every time somebody turns on a local news channel, there's always what's now very familiar to the public, a media spot on what are the spring flow levels now, what's the target, are we in trouble or not, what kind of urban water use restriction phase are we in at this point. So the urban areas have been very aggressive in this area. Monitoring, by the way, on the endangered species population suggests that the strategies they're adopting are adequate to meet the federal requirements for trying to maintain those spring-dependent species. So regulatory triggers look like this. This is the regime that's currently in place. These are a particular monitoring well, meters above sea level on our vertical axis, and then different levels of the aquifer at that measurement well in the shaded area, and then the mandatory restrictions in your pumping permit, the amount of water you're allowed to permit showing here. The first restriction is at a go down 20% from what your permit is in a typical year, all the way down to 44%. They do put a bottom on how much they can require mandatory cutbacks and groundwater pumping, because there's other programs in place as well to try to meet some of these spring flow requirements. So they have the compulsory tool, reduce allowable pumping, that I just referred to. And then they have 2 voluntary programs, 2 voluntary water trading or market-like programs, paying irrigators to suspend use of permits for a short duration period. That's the voluntary irrigation suspension program. So you're a farmer. If this looks good to you, and we'll look at the payment amounts in a minute, you sign a 5-year contract, And the Edwards Aquifer can notify you in the fall that you're going to have to cut your pumping back by a certain amount because you've enrolled in this voluntary program, and you have enough notice to do that, to plan your crop rotations and minimize disruption to your farm planning cycles. So this first program, VISPO, is a short duration respond to what is seen as an immediate problem over the next few months with spring flows. And then this is a new program, the Aquifer Storage and Recovery Program, introduced in 2017, is a long-term program with 10-year contracts. And in that one, you're asked to cut back pumping, again, based on a trigger, but the trigger isn't spring flows or monitoring well, it's actually the 10-year average of recharge to the aquifer. So our second program is looking at response to long-term drought conditions. Just to see a little bit about what the paying in the long-term drought program, the ASR, payments of $100 an acre foot, I can assure you that's at least 10 times more than you would earn using that same acre foot of water to grow crops. In this area, you're signing 10-year contracts. The trigger is looking at long-term recharge rates in the basin. And then over in the short term, let's take care of things that are going to be a problem at the springs in the next few months is the program. On the other side, you're being paid in the years you actually have to cease pumping, $160 per acre foot, and a standby payment in other years of quite a bit less than that. But in those other years where you're getting your $54 an acre foot, which is still far more than you would earn in terms of net income, growing crops, given the crop mix in this region, you're getting $54 an acre foot, even though you're proceeding as normal with your farming. So there has been a changing understanding of the Edwards Aquifer over time. In the 1990s, the aquifer was seen as something like a large underground lake. Well locations weren't observed to be important in terms of setting up trading patterns. So trades could occur on an acre foot per acre foot basis throughout the entire trading region that was governed by the Edwards Aquifer Authority. Just in the last decade, there was a realization that along the lines of a certain creek that runs through the aquifer, on the side of that creek closer to the springs, it became clear that pumping in that area had a much more significant and quick impact on spring flows than on the other side. So they created prohibitions and special restraints on transferring water into the zone closer to the creek. So if that meant that you already owned a pumping permit closer to the creek, you already had the right to do that, you were not regulated, those water rights could be traded anywhere, but you couldn't do trades that would cause new pumping to move into that area by buying up permits from somewhere else outside the area. This doubled the market value for those pumping permits located in that special zone, about $10,000 an acre foot at this point of time, compared to about $5,000 an acre foot for a permanent retirement, permanent transfer of that pumping right. So you can see the importance of spatial distinctions in groundwater trading programs. Bringing us up to 2018, the Aquifer Authority is administering a pumping cap of 572,000 acre feet. That's up quite a bit from the old 450,000 acre feet. It's focusing on both the mandatory and voluntary programs to achieve required spring flow levels, and it's got new challenges. Takings litigation has received a lot of attention in Texas. I've heard many interesting talks by water attorneys on these cases. And the fact that there have been some successful takings cases in awarding high levels of compensation to parties who did not receive the groundwater pumping permit that they thought they should have, $4 million in one particular case in 2016, means that the Edwards Aquifer Authority is facing a threat of, if these takings cases are found to extend to a broader set of parties and compensation continues to be this high, that's a huge financial burden on their operations as it's still unfolding over time. For the many economists, many of my colleagues in the room, these takings cases and the calculation of the damages are really interesting for us. So if you're a damages and valuation geek, this is fun reading. I enjoyed looking at them. Another ongoing challenge for the Edwards Aquifer is the proliferation of exempt wells. And of course, this is a problem in many areas of the West. Wells under a certain size, in this case 25,000 gallons per day, are not counted in the permit system here. And so when mandatory curtailment occurs on pumping permits, some parties, kind of weighing the trade-offs to themselves, the the financial cost versus having an exempt well and what it will do for their operations, go ahead and drill exempt wells, a non-trivial number of these cases. So far, there's no regulatory authority to deal with that loophole. So again, that remains. And if you live in an area that has tackled the exempt well problem, you know how politically difficult it is to do that. The other thing I'll mention here is that fracking water use is increasing rapidly here. Fracking water use still needs a permit like the other groundwater users in the basin, but they've been driving prices up in a way that's really changed market conditions and putting a lot of political pressure as well to see if there's something could be done to make groundwater more reliably available for fracking use, even in dry years. So that's creating a lot of interesting pressures in the system. We have a talk coming up on the Upper Rio Grande, the San Luis Valley in Colorado next. This is one of the water trading areas or special water incentive programs I like to mention because they have such an innovative mix of federal, state, and local funding and partners in this program. I'm sure we'll hear more about that. And this program has the advantage, and this is one that economists again think about, if there are important spatial differences in how the aquifer behaves, you want to make sure that's incorporated in the trading rules, and you know it's going to show up in the value of the groundwater permits as well. It's a somewhat different situation here in the Upper Rio Grande, but they do target reductions in pumping and the incentive payments for that based on where it's spatially advantageous to do that, given their mission of stabilizing the aquifer and assuring that Colorado meets its compact requirements on the Rio Grande. The other case I always enjoy talking about when I'm talking about sophisticated groundwater trading programs is that of Nebraska's natural resource districts. About a half dozen of these districts now have with varying degrees of activity, online groundwater trading programs for the purpose of paying groundwater users to reduce their pumping in specific seasons and, of course, at the specific well locations in order to assure that Nebraska doesn't run into trouble with its interstate compact requirements, that's in the Platte Basin, and to meet endangered species flow requirements, which are important in different areas of Nebraska. And in this case, the farmers who are paid to cut back their pumping are paid in an unusual way that I hope that we see more of, and that is the impact on surface water flows. So I'm Farmer Jones, located 10 miles from the river at a certain gradient. Groundwater model has been adopted in this region that is used for these purposes, groundwater surface water models, and that tells how flows are going to improve and in what seasonal, what time lag, given my reduction in pumping. I'm paid on that basis, not on the basis of change in how much water I cease to pump at my well location. Very important nuance here, and I think it gets the incentive signals correct in a useful way. Of course, it relies on having a groundwater surface model that has been adopted and will stand up to any litigation tests that come. And fortunately, in a number of these districts, that's in place. And the online trading platform does those calculations, so Farmer Jones knows how much he's going to be paid for reducing his pumping, say, by 1,000 acre-feet per year, and what the impact, and the river managers know what that means for impacts on surface water flows. So groundwater trading is very much a maturing process, going from high conflicts, unmarked vehicles, and personal safety protocols for the water trading team to lower transaction costs, better information on prices. And today we have dozens of water trading programs operating around the western United States focused on groundwater. Spatial distinction is important. They need to be built into the trading rules. This requires excellent cooperation between the hydrogeologists, the attorneys helping set up the program, as well as the economists and other specialties. We need to always be prepared to have the trading rules, a good process in place for adapting those to new understanding of surface water and groundwater. Our environmental water programs do and need to continue to do in the future. Pay attention that groundwater trading programs are well designed and that environmental water programs take advantage of the ability to alter pumping levels in places where that's the most strategic way for them to proceed. Different trading programs would be structured differently for long-term drought versus short-term needs. And thinking about different kinds of trading programs in the same area, this has worked well in a number of cases. And the threat of outside intervention because of that subtle, gradual, lagged effect of groundwater overdraft having a threat of outside intervention from one source or another has been useful in many, many cases. And if I had given my talk the name that really applies, now that I've spent a little time looking back at some of my experiences and those of others with groundwater trading programs, courthouse, marketplace, full employment for many of us and our graduate students. Thank you.
Bonnie, since we are running late, I'm tempted to skip questions, but I want to do this under the guise of, I know you have a sore back and shouldn't be standing too long, so we just can't impose on Bonnie any longer. So if you have questions for Bonnie, catch up with her.
Oh, yeah, we can see at the end, you know, if you call everybody up the front, we can do that too.
If we have some time.
Sore back is recovering from hip and spine surgery, and I'm just happy to be here, as a matter of fact. Thank you.
Thank you, Clark. All right. But you did a wonderful job of providing the transition to our next talk by Cleave Simpson, who's the general manager of the Rio Grande Water Conservation District, which is in southeastern Colorado. He's also a fourth-generation San Luis Valley farmer. And the San Luis Valley, Bonnie mentioned, and actually one of her pictures was the San Luis Valley. It's very, it's a gem. I mean, it's not a lot of people, I think, know about the San Luis Valley, but it's a wonderful place. But it's a place with a long history where groundwater is controversial, not only in terms of conflicts between surface water users and groundwater users, but also in terms of some front range cities have always had their eye on these big groundwater reserves in the San Luis Valley that they wanted to take out, which I think that threat helped mobilize the people in the valley to get their internal house in order. And I think it is a success story, but you can talk me out of it if you don't agree, but I think it's...
No, absolutely a success story. Thank you, Doug. Pleasure to be here today, and you've kind of covered everything already, so I'll entertain any questions, and we'll speed the program up a little bit. Again, it's a pleasure to be here today. I appreciate the opportunity to speak to folks today about what I'm passionate about, and as the title of the program today, about what lies beneath and reasons to care. Again, Doug touched on it, so I'm a fourth generation San Luis Valley farmer and rancher. And today my 27-year-old son's home trying to finish planting our crop for the season, and so that would be the fifth generation. He hasn't produced a sixth generation for me yet, but I mean, that's why it's important to me, and that's why I'm passionate about groundwater, and specifically in San Luis Valley. And my title of my program is Learning to Coexist in the Upper Rio Grande. So that implies, if you're coexisting, that implies some interaction between competing interests, and Doug kind of touched on it for me already, so I'll review a little bit of the history, but that coexisting parameters really between groundwater and surface water users. But it's really above and beyond that. It's really probably, the title probably could be How Do We Exist? So I'll talk about that in greater detail as well. See if I do this right. Yeah. So a shameless plug for the Rio Grande Water Conservation District. If you happen to be in the San Luis Valley or Alamosa, please stop by. It's a wonderful, relatively new facility. We built it a couple years ago. Really highly utilized. We had our first, the opportunity to have 100 or so people gather in one place in Alamosa is a little limited. We got to break in the building with the Rio Grande Compact Commission, Texas and New Mexico and Colorado a couple years ago. Any number of water users, conservation groups, but I would also highlight that earlier this year, the local water court chose to conduct really probably the most significant water court trial in the last decade or so for us in our facility. So the local judge, Judge Patty Swift, chose to use our facility, so it came in really handy. And I'll apologize in advance to Regan. I use this routinely. Location of the Rio Grande Water Conservation District. By intent, it was located really close to the San Luis Valley Mental Health Center. So that does at times come in handy. And actually now under construction next to us is the new Judicial Center, which will include District Water Court. So you can walk to court, to the San Luis Valley Health Center, and back to the district. All right, we'll cut to the chase. Let me keep up with my notes. This is a representation, a graph of the condition or the change in the condition in the unconfined aquifer in the San Luis Valley. And the district has been monitoring the condition of this aquifer really since 1976. I have an employee that goes out once a month and gathers water level readings. We bring them back into our district engineer, and we've plot and graphed the change in the aquifer again since 1976. But you can see, since we started, there was fairly consistent supply of water in the basin right up until the point 2002. And much like generally across the West in Colorado, the Rio Grande suffered the worst drought in our recorded history in 2002. I'll show you a hydrograph later, but the Rio Grande at Del Norte's gauge traditionally averages about 650 to 700,000 acre feet. In 2002, the flow at the Rio Grande was 125,000 acre feet. We rely extensively on the Rio Grande, both for direct surface water applications, but also a recharge of both our unconfined and confined aquifers. The other important point to note here is along about the same time in late 1990s, well administration was being implemented on the South Platte with some pretty devastating effects to well owners and producers and farmers on the South Platte. Those kind of circumstances and instances put forward an effort in the valley from the producers to introduce legislation. We traditionally call it Senate Bill 222 in 2004 to give us a mechanism for some self-governance and control over both aquifer condition and well administration. So Senate Bill 222 was codified under Colorado Revised Statutes 3792-501 in 2004. And really I just highlight the state engineers to develop and adopt and promulgate rules and regulations that prevent material injury to senior surface water rights, and really for us, create and maintain a sustainable water supply in each of our aquifer systems, both the unconfined and the confined. So what's on display here is something I borrowed from the Division of Water Resources and their application to the state for promulgation of rules and regulations for groundwater withdrawals in Division 3. So again, that case, let me take a step backwards. The state recognized the need and the necessity to model and understand the impacts between groundwater and surface water users really since the 1950s and 60s. We had there was an effort in the 70s to promulgate rules and regulations about groundwater withdrawals. The state engineer put those forward in the late 70s. Those were challenged to the Colorado Supreme Court and were denied. In the interim, there were some efforts to mitigate that injury through some other sources that kind of held us together for a little bit of a time till 2002, and that again was a big trigger that we got to do something different. So the state really took a tremendous amount of time and effort to create a groundwater model. A lot of what you've heard this morning from a number of the speakers applies to a lot of what I'm talking about today. So within the basin, the state has modeled, the red outline is the extent of the groundwater model. This will come into play. The state then developed response areas. Response areas are generally areas of community interest. We have either the same types of wells, similar hydrology. A lot of it has to do with the distribution of surface water systems. But it ended up being really identified as really communities of interest. So response areas ultimately have the ability to, and I'll talk about them, become sub-districts of the Rio Grande Water Conservation District. So by statute, we have the ability to create sub-districts. So the first one, like I should have highlighted when I showed the graph with the precipitous decline in the aquifer, and in the unconfined aquifer, that aquifer generally resides and almost matches the footprint of what sub-district number 1 is. So the state created response area for sub-district number 1. I'll highlight a little more about it, but it's up and running and has been operational now for its 7th year. The district has been working really exhaustively for the last 6 or 8 years to bring other sub-districts online. So we have approval and the creation of sub-district number 2, which is a system of shallow unconfined wells, roughly within a mile or 2 of the river, generally between Alamosa and Del Norte. We have also created what's now sub-district number 3, which is the Conneaus response area. We've created sub-district number 4, which is the San Luis Creek response area. We've created sub-district number 5, which is the Saguache Creek response area. And if all goes well, next week we have a district board meeting and we'll present the petitions to create what will become sub-district number 6 of the Rio Grande Water Conservation District. But I would highlight a little bit of history. Many of you probably know the oldest adjudicated water right in the state of Colorado is in the Rio Grande Basin. It happens to be down here in the Costilla area, which is not part of the Rio Grande Water Conservation District. When we were formed statutorily 50-some years ago, the residents of Costilla County chose not to be part of the Rio Grande Water Conservation District. So there's some unintended consequences of doing that now because they can't form a sub-district underneath the Rio Grande Water Conservation District. But with the development of surface water diversions in the system, again, that started in the late 1800s, 1870, 80, into the 1900s. By the early 1900s, the Rio Grande Basin and system was already highly over-appropriated. More applications for water rights than generally water was available. I've heard some discussion about, the introduction of vertical turbine pumps in the 50s and 60s, and in the valley, access to electrical distribution became this proliferation of development of groundwater systems for irrigation purposes in the San Luis Valley. It wasn't long after that development of those systems, the state and the producers started realizing there is some sort of interaction between the groundwater system and the surface water systems. The state engineer in 1972 issued a moratorium, no more confined aquifer wells. That stood in place and was challenged later on in an export scheme that Doug mentioned, and was upheld in court that there is no unappropriated groundwater in the San Luis Valley. In 1984, the state issued a moratorium on the unconfined wells in the valley. So with the advent of response areas, the state now has the ability within those response areas to, with some degree of confidence, predict what the interaction and the injury is to surface water systems inside those response areas. So that when the rules become effective, producers or owners of non-exempt wells have 3 options to comply with these rules and regs that were argued in earlier this year. You can either have your well and your property included in a sub-district of the Rio Grande Water Conservation District that has a court and state-approved groundwater management plan. You can have an augmentation plan, your own individual augmentation plan that meets the same criteria as was outlined in statute about mitigating your injurious depletions and creating and maintaining a sustainable aquifer. Or lastly, when the rules become effective, you would have to abandon the non-exempt use of your well. So I'll spend a predominance of my time talking about what is sub-district number 1. So that response area outlined is basically the footprint of sub-district number 1. You can see it's an intensely intense agricultural production section for the valley. There's roughly about 175,000 acres of irrigated ag, a huge economic driver to the San Luis Valley. Raise potatoes, barley, alfalfa. We raise some quinoa, some canola, some limited amount of vegetables, some carrots, but potatoes and barley and alfalfa are the biggest crops grown in the sub-district. So this sub-district historically was withdrawing or pumping about 300,000 acre feet of water on an annual basis from about 3,000 wells. So again, with the decline in the aquifer in 2002 and knowing what was happening with rules and administration of wells in the South Platte, producers really came together and said, we gotta have a different outcome than what's occurred on the South Platte, and we also have to figure out how do we create and maintain a sustainable aquifer on our own. This is in advance of the state coming up with its own set of rules and regulations. So in 2004, along with the legislation, producers started to come together and talk about how do we structure this, how do we develop a plan that we can really maintain our agricultural production the way we have. That process is sitting down one-on-one with producers and explaining a plan and the condition of the aquifer and the interaction between the groundwater and the surface water, and then getting them to sign a petition that, I always say this, it really encumbers their property. It puts that property in the sub-district in perpetuity. So the visionaries that put the first sub-district together drew the boundaries, sat with producers for 2 years, a lot of kitchen table talk one-on-one, because by statute we have to get 51% of the land and 51% of the landowners to sign a petition then to submit to the court, the district court, for creation of the sub-district. So that took some effort to get through. The sub-district was approved in 2006. We developed our first plan of water management, submitted it and got it approved by the state engineer in 2009. There was enough organized opposition to the plan. It got challenged to the Colorado Supreme Court, and it was probably as much about the modeling effort and did the model do a significant job, and was it producing reasonable results. So if you can imagine, if you're a surface right holder only, the model wasn't aggressive enough and didn't show all the damages that you thought occurred. So anyway, it was challenged to the Colorado Supreme Court. The district and the sub-district prevailed. The plan of water management was approved in 2011, and we started our first year of operation in 2012. So this was probably really our first significant effort to coexist. But again, it was as much about self-preservation and existence as it was about coexistence. And it's really mindful and important to think of not every parcel in this sub-district boundary agreed to or wanted to be part of the sub-district. Roughly half of them had no interest in pursuing this. So it was not an easy charge to get to the 51%. It was a rather difficult process to get there. And really because of what you're talking about, adding really in farmers' cash flow, another line item for an expense that agriculture in general and in the San Luis Valley's pretty marginal to begin with. And now you talk about adding another expense, it really becomes questionable if it's worth what we're trying to do in some people's minds. So with an approved plan of water management, on an annual basis, the sub-district puts together an annual replacement plan. That replacement plan, we predict what the pumping's going to be. We use the state's tool. It's called a response function. We use their tool to predict what the injury is to, in this instance, this group of wells in Sub-District 1 only have an impact on the Rio Grande River. So we use their tool to predict the injury. We submit to them on an annual basis that prediction of the injury and our portfolio of tools and resources to mitigate the injury. We do that in early April. State engineer has some time to review that. And by 1st of May, he issues an order that says, yep, you can operate this year. We truly run the risk on an annual basis of the state engineer saying, if we're not really diligent in our application, we run the risk of the state engineer denying our annual replacement plan, which when rules become effective, then would instantly shut off all 3,000 wells in the sub-district. So we work really closely with the state engineer. When he gets our annual replacement plan, there are no surprises about the impact or the mitigation. So again, the object of the sub-district and by statute is to create and maintain a sustainable aquifer and mitigate the predicted injury to surface water systems as a result of sub-district well withdrawals. So to do that, you can appreciate you need a revenue stream to do that. So this sub-district's concept was to administer or really assess 3 fees on producers in the sub-district. A per acre fee for administrative costs, a CREP fee, and I'll define CREP in a little more specific terms in the next slide, but that's a program the previous presenter referenced to about a partnership with the federal government. We set, and these are max, we set a maximum fee of up to $5 per acre. We set a maximum fee of up to $12 an acre for the CREP program, and that's really all about aquifer recovery and sustainability. But the other one, the big kicker, is what we call our variable fee. That's a fee of up to $75 per net groundwater acre foot pumped. We use those to fund water acquisition and storage costs and aquifer recovery as well. So those fees are determined, I'll take a step back. The revenue needed to operate the plan is determined every year on an annual basis through a budgeting process. You identify what revenues you need, then set the fee to support that revenue stream. We submit those, the sub-district submits them to the district board for approval, and then upon district board of directors approval, it then goes, we submit those to each county. So in this instance, that sub-district's partially in Alamosa County, Saguache County, and Rio Grande County. We submit those fees to the local tax, the treasurer. The county then includes those on individuals' property tax notices the next year. There's a line item on their property tax statement that says Special Improvement District Number 1. The county collects those. You can't choose not to pay those. They become a delinquent property tax, just like your school tax or county tax or anything else. So you can't selectively not pay your Special Improvement District tax. The county collects them, redistributes them back to the district for operation of the plan. So what sub-district number 1, again, had 2 basic requirements: create and maintain a sustainable aquifer and mitigating the injurious stream depletions. So again, from the graph, the sub-district chose for its sustainability requirement in an effort to recover the aquifer at a very minimum back to this minus 400,000 acre feet from the 76 baseline. So there was a lot of thought amongst the producers in establishing what that sustainable aquifer looked like. So at this point in time, the state didn't have a requirement for the sub-districts, and particularly this unconfined well system of sub-district 1. But at minus 400,000 acre feet, all of the producers and all the constituents in sub-district 1 had a full supply of water, was the general consensus. So that's the target, try to get back to there. And actually what we have to do is move this, the red line's the 5-year running average of the change in the aquifer. We have a 20-year time frame to move that line from there to a minimum up to there. Pretty challenging. 2012 was a pretty tough year, our first year of operation. After that, though, the next 4 years were, at least for the Rio Grande, were at or very near average, and we saw the beginnings of a nice recovery in the aquifer. So that's about 350,000 acre feet of recovery over that 6-year period. Hopefully, this had better be our low spot in our change in our aquifer storage. And again, that's about when the sub-district started. 2012 was our first year. So a pretty significant challenge for the sub-district. And again, keeping in mind, something a little less than half of the participants in the sub-district either didn't want to be in the sub-district or thought it was not a noteworthy effort. So our mechanism for creating and maintaining a sustainable aquifer, the original plan and the business model they put together relied on something called a Conservation Reserve Enhancement Program. So to move that 5-year average change in aquifer up to minus 400,000 acre feet, in 2006, given what climate conditions were like in the prior 12 years, it was identified the sub-district really needed to retire about 40,000 acres of productive agriculture out of the sub-district. The concept was, rather than eliminating 40,000 acres or buying producers out, there was an opportunity to partner with USDA and Farm Service Agency and the state of Colorado in a CREP program, Conservation Reserve Enhancement Program, where the federal government pays producers. Let me take a step backwards. So the program is a 15-year fallow program. It can be 15 years with permanent groundwater retirement. It can be 15 years with temporary groundwater retirement. So after 15 years, some producers then could actually go right back to productive agriculture if you believe you can idle productive farm ground for 15 years and bring it right back into production. So that the thought was to create a bit of a soft landing for producers to go, let's use the CREP program. You get paid. At that time, we thought at least competed with market prices specifically for barley production. Problem happened right after we got the program. Market prices increased. It was hard to get people to participate in the CREP program. So as of today, we have, and again, the target was 40,000 acres. As of today, we have about 8,000 acres signed up in CREP. About 60% of that is in a temporary program, and only about 40% of it is in permanent. The sub-district also does some self-funded shorter-term fallow programs. Again, part of the lack of attractiveness to the CREP was it's a 15-year commitment. Plus, it's very rigid. You sign up a parcel, usually a sprinkler quarter, 120 acres, and that's the one that has to stay in fallow for 15 years. So I might highlight there is a 3-year window to get some sort of native vegetative cover established under that 120 acres with some minimal water application before it becomes a permanent fallow program. So given that it was the length of time and the rigidity around it, the sub-district recognizing while we had made some progress, we weren't progressing fast enough to meet that minus 400,000 acre feet requirement in 20 years. So the sub-district stepped up and funded on its own a 4-year fallow program where we just pay producers $200 an acre to fallow their quarter for 4 years and then give them optionality. Keep in mind in the valley now, I don't know what the average is, but producers own or operate really to be a viable commercial farming operation. It takes 10 quarters usually, 10 or 12 or 15. The day of trying to raise a family on 1 quarter, it just doesn't exist anymore. My dad and I, we farm a dozen quarters and sprinkler quarters and some flood ground and some irrigated meadows and pastures. But anyway, given producers that flexibility, we just started that program this year. We got about 2,000 acres signed up this year. But it was ironic because it was in direct conflict with, given current conditions in the Rio Grande, which are nightmarish from water supply standpoint. Projections are for the Rio Grande, it's not going to be quite like 2002, but Right now, the state's prediction of stream flow forecast for the Rio Grande are 300,000 acre feet versus that average of 690. But that also within Subdistrict 1 especially opens the window or the door or the opportunity for insurance coverage, something called prevent planting. So when conditions present themselves and farmers have been participating in these insurance programs for some period of time, they can actually apply for prevent planting and get paid not to plant. And some of those paid better than what our proposed fallow program was going to pay. So, but it's generated some interest. So the other thing we do with the funds that we raise, we've done some amount of property acquisition and permanent retirement of groundwater. So it hasn't been high on the list because we're really not set up to be property managers. As a matter of fact, we made an acquisition last year from the Nature Conservancy of 8,000 acres. Now there was only about 300 acres of irrigated farm ground. The balance of it is dry land pasture. So if you have an interest in 8,000 acres of dry land pasture, please come see me because we would make you a really good deal on that. And it does border the national park, the Great Sand Dunes National Park, so great views too. The other thing we fund and pursue is last year we were successful in an application for an RCPP where we partner with the NRCS and cost share with producers practices that improve groundwater conservation efforts. A lot of it has to do with some weather stations, groundwater moisture monitoring systems, some cover crops. So that's new for us, but we have a little bit of interest in that going forward. So that would kind of highlight what our focus is and our efforts around aquifer sustainability. The other thing we have to do again is mitigate injurious stream depletions. So we do that through leasing some water rights, some outright purchase of water rights. We've done a little bit of that. And ironically, so this isn't forbearance of pumping, but this is a forbearance agreements with injured surface water right holders. So if our predicted injury says on a daily basis, because of the production of the wells in Subdistrict 1, the Rio Grande River is 10 acre feet short or 5 CFS short for the day. Whatever calling right or calling priority is supposed to be getting that 5 CFS, we uniquely have the ability, I think this is unique to us in the state, we can remedy that injury with something other than water. So I always tell people it could be a load of hay or a blanket and 2 horses, but it's just been a cash exchange. But it's worked reasonably well, and it's really going to be key for us when all sub-districts are up and running. The magnitude of the impact to the rivers and systems is somewhere between 15 and 20,000 acre feet on an annual basis. We don't have access to 15 or 20,000 acre feet of water to mitigate that injury. So forbearance agreements are going to be really key to us. We've utilized them in Subdistrict 1 with great success over the first 5 or 6 years of our operation. So moving along, I just wanted to throw up, this is the effort we go through with the state and their response function about calculation of those stream injuries that we have to mitigate. And I was just going to highlight, so, and we've also only been metering and reporting groundwater withdrawals in our basins since 2009. So prior to that, everything is modeled or guesswork about what withdrawals were occurring in the aquifer. But you can see Subdistrict 1 was going from well over 300,000 acre feet of withdrawals to this year we predicted 260. We've had years where it was as low as 205,000 acre feet of pumping. So we had, a significant impact, some from our CREP program and fallow programs. Really, some of it is from there just isn't water to pump. So when the aquifer dropped as much as it has, some farmers have to make some choices. They don't have an adequate supply to farm a full circle. So in parts of the sub-district, you'll see a number of producers just farming half circles, and that's why. But I wanted to also highlight the state recognizes, and we have the unique capability here to recharge our unconfined aquifer. Those 4 ditch companies have a recharge decree right. So they divert out of the Rio Grande. We put it in recharge pits inside their system, and then producers basically get to pump that water out one for one. So when I talked about our net fees of $75 an acre foot, those producers that, especially these folks that own shares of Rio Grande Canal, a number of the producers in Subdistrict 1 never have to pay that $75 an acre foot. They generate more credits than they do pump. And we actually have a system where you can market and trade those surface water credits. So that's unique. But you can see the recovery of our aquifer also kind of coincides with this net groundwater consumptive use, which is really just the difference between the groundwater consumed and how much gets recharged. The aquifer recovered in these periods and declined in these, and it's set up to decline this year. So a little scary for us. We've worked really hard to recover about 350,000 acre feet in the aquifer over the last 6 years. We can and have in 1 year diminished 400,000 acre feet in the aquifer. I don't think that'll happen this year. We don't pump as much as we did. People are more educated and more in tune and realize if we don't meet that requirement in the next 20 years, we're subject to complete curtailment by the state engineer. And the outcome out of that net groundwater consumptive use, out of the state's model and their response function, we generate stream impacts that have to be mitigated on a monthly basis by stream reach on this instance, just in the Rio Grande. All the other response areas have their own response functions, and they'll have different impacts to different streams going forward. Just quickly for perspective, the revenues generated by our variable fee, we have the ability to raise it to 75. We started the first year at 45. I've heard some reference to this morning to lagged impacts to pumping, so those we call post-plan depletions or post-plan impacts. In our plan we submit to the state every year, we have to have the mechanism or show to the state we have the ability to mitigate those post-plan impacts. When we started this process, Subdistrict 1 had about 40,000 acre feet of post-plan impacts that were spread out over 20 years. So we didn't have 40,000 acre feet of water to store. We don't have that kind of storage to begin with, but we could satisfy that requirement from the state with money. So if we had $5 million set aside in a pool available potentially to the state in the event the subdistrict failed, somebody was on the hook to mitigate those injuries over the next 20 years. Anyway, that's what precipitated the subdistrict really having to move immediately to $75 an acre foot. But you can see the revenue that we generate on an annual basis. I talked about the surface water credit offset, and this is the same total pumping that was on the previous sheet. I got one slide left. Just quickly, the other sub-districts have different sustainable aquifer recovery requirements. The state, under the current rules, has basically mandated that each of these other response areas, or they're all sub-districts except this one now, have to, their 5-year average groundwater withdrawals cannot exceed the state's modeled 1978 to 2000 groundwater withdrawals. The other sub-districts, 2 and 3, should be operational next year, and they'll have these kind of sustainability requirements going forward. Lastly, what a challenge for us in the Rio Grande Basin to manage aquifer recovery and sustainability, given the long-term trend of the Rio Grande. And I'll note, there's not been a single decade since we've been keeping records that the Rio Grande has not at least had 1 year at 700,000 acre feet. We won't make it this year unless we have a really good next year. This will be the only instance in history where we have a decade where the Rio Grande didn't flow 700,000 acre feet at Del Norte. Thank you. Thanks, Doug.
Sure. We are getting pretty far behind, so we will skip the questions, and I hate to do that, but I want to try to make sure that our next presentation has enough time, in part because our next presentation is complicated enough and is broad enough that we have 2 presenters. And And these are two presenters who both have worked in the Diamond Valley, but aside from that, they seem like the two of the most different people you're ever going to run into. Or I think we'll start with Sam Routson, who kind of gave me the Forrest Gump treatment when we talked on the phone, in that he said, at one point you described yourself, I think you used the word simple potato farmer, even. Maybe you said potato farmer, and then I'm thinking, then I'm listening to him, and he's kind of lowballing me here, and he knows all these things. And then I see his bio, and you really should read the bio. Amazing history in there, including his military background, Marines and so on. The Deputy Assistant Secretary of the Navy under two different presidents. All these things. And then he also has a law degree, but is one of 4 degrees that he has. And he is a farmer, and he's associated with Winnemucca Farms, which is a huge, from what I can tell, potato farm in northwestern Nevada. So he's got a lot of different perspectives, but he was kind of one of the local perspectives in Nevada when they set up this scheme. The other presenter here is Mike Young, who is, I'm going to use Bonnie's term. Mike Young has water markets fever, I think, to use Bonnie's term. He's from the University of Adelaide, and he's come here from Australia just to speak to this group today. So, I mean, that's some serious commitment. Mike has worked all over the world and to try to set up water management regimes that take advantage of economic principles, including in this case in the Diamond Valley in Nevada, but a lot of other places as well. And so they're going to do a tag team. Well, Sam will start things, and then Mike will conclude things. I think that's my understanding of the plan of attack here.
Doug, it sounds great.
And
we'll see how it goes.
We will see how it goes. So, all right, take it away.
Well, good morning, everyone. And Doug mentioned, read my bio. Those things. It's lies, distortions, and half-truths. And you read these bios of some people, and you say, "Man, oh man, that's crazy." Second man to walk on the moon, Nobel Peace Prize for curing cancer, and the kind of these things. And I often wondered, who actually writes these things? Who puts these together? Now, I don't know who may have done it in other cases, but as for me, and I don't know if you're out there, but if you are, thanks, Mom. And if I could just ask your indulgence for just a moment, I would like to introduce a young colleague. And as you can see, a lot of water has flown under my bridge. I'm still working in these different things, public policy, public management in the Northwest. But we need young individuals to come behind us and to be interested in what is going to be in the future, as was said by Dr. Megdal and Dr. Conoco earlier this morning. These are going to be critical policy issues. Whether our policymakers realize it or not, it's going to be forced upon them that have to be dealt with. And I have a colleague of mine here, young Matt Ketelopper. Matt, stand up so people can see the kind of young people that are actually coming into the water space. And I envy these people because they are coming in at an exciting time. And these young people, they have new ideas and they have energy, and they're just running wild, free, and naked. And I say that figuratively, of course. However, in Matt's case, it might be actually more literal than figurative. But nonetheless, what we're going to talk about, and may I call your attention to these two documents. One is Diamond Valley Groundwater Management Plan, and the other is Unbundling Water Rights, a blueprint for development of robust water allocation systems in the western United States. And they should be, Sean, am I correct? They will be on the conference site?
Yeah, I have the Diamond Valley on the conference site now. I don't think I know about the other document.
Well, we'll provide that so that you can get it on. Now, so far this morning, you've had, and I understand that you are experienced in the water sphere in different aspects of it. And we've had presentations dealing with this, and presentations of dealing with how these areas have been addressed, two case studies in Edwards and San Luis, and their more mature plans about how these local issues have been dealt with in a public policy and a actual management situation. Now we're going to turn our attention to another issue or another case study where it's not mature. In fact, it's in progress. And the individuals, the stakeholders involved in this have just received the certified letters and the petition for signatures on a groundwater management plan. And so, and as I start this, I want to give a special recognition and note of thanks to an individual by the name of Jake Tibbetts. And Jake is the Natural Resources Manager for Eureka County. And to a large degree, it was Jake, and I think in all of these issues, as we face these issues, we're going to have, and we're going to have to hope for, individuals whose personalities are such that they can deal with these very controversial and very emotional issues. They're going to have to be individuals that have the patience of Job and the compassion of a Mother Teresa. And in fact, I expect we'll receive an announcement any time from the Vatican that Jake is going to be canonized. So now, this is a study of Nevada. Now again, Nevada is not necessarily unique. In all of the western states of which you come from and which you're familiar, whether it's Texas or Colorado or Arizona or New Mexico, Utah, California, and so on, we face these issues. Now, however, in this case, Nevada is the driest state in the nation, and we get approximately 8 inches of annual rainfall, and that includes people spitting on the ground. And, how did we get into this situation? Again, Nevada is not unique, but we have the legislation, for instance, and it's the variations of the Homestead Act, the Desert Land Entry Act, where the purpose, the public policy at that time was to open up these arid and semi-arid states. And of course, the Reclamation Act of 1902. And these actually had very positive results. They were very successful in their intended purpose at the time. So what could possibly be a problem with that legislation that caused tens of thousands of people to come into these arid and semi-arid areas? Well, as Puck said, Lord, what fool these mortals be. We had just a little bit of unintended consequences. No water. Doctor, as you said this morning, we're facing a situation where you have either it's Mother Nature or it's a very large demand on a very scarce and sometimes non-existent resource. No water, nada, zip, nothing. And so we're going to talk about this case study now. We're actually up here in Winnemucca. We have a farm. It's about 29,000 acres. And if you're familiar with Pringles potato chips and Frito baked Lays and Colby pea snacks, well, that's summertime. And so I would encourage all of you in this summer season of picnics and family outings to purchase and consume prodigious amounts of those products. Very good. And at another time and place, we might talk about a aquifer storage and recovery project that we're looking at. I just filed on 300,000 acre feet of floodwater here in the Humboldt River plain. And it's a little bit controversial, but it's very interesting. And we believe that this is the type of water policy that needs to be implemented. These are the types of projects that will allow us to deal with a very scarce resource. But we're going to talk about Diamond Valley. It's in the center of the state. It's a little rural town, as you'll find in many areas of Texas and Arizona and Utah and Colorado and so on. It's actually a unique little valley. And within this valley, and it's you can tell it's bordered. This is almost a classic. There's no inflow outside of the basin, and there's no outflow from to anywhere outside of the basin. And we're dealing with groundwater here almost exclusively. And it's 25,000 acres of agricultural ground that is farmed and sustains this little community called Eureka, Nevada. To the tune of about $23 million in crop sales. So it is key, it is essential to this little local area. However, we have a problem. Diamond Valley has about 35, as determined by the state engineer, about 35,000 acre-feet of perennial yield. However, there's 186,000 acre-feet of year permitted water. And this is a result of those acts, the Desert Land Entry Act and so on. They never thought that there would really be this demand. But as has been mentioned before, here again, Diamond Valley, with the introduction of electrical power into the valley back in the 50s and 60s, farmers and ranchers saw an opportunity to take advantage of that technology, if you will, and put in pumps that exponentially increased the demand on that aquifer. Now, last year there was about 76,000 acre-feet pumped for crop production. Now, of course, Nevada is a prior appropriations, Colorado doctrine kind of state, first in time, first in right. And prior appropriation works until you get upside down, as in Diamond Valley. For the last over 60 years, the aquifer has been depleted 2 feet per year. So it's been depleted several hundred feet. That is not sustainable. And so they're looking at a situation, if you look at just what is the state engineer going to do, how is he going to manage it? Well, he has no choice because that has been designated a critical management area. And he has no choice but to manage that area by first in time, first in right, and shutting down a majority of the growers and producers in the valley. So you go from a situation like this to perhaps a situation like this. Now, in the 2011 session of the Nevada legislature, the legislature looked at this and said, boy, that is very draconian. That is not going to be good on all of our rural counties and the people that live and work there and sustain themselves and their families and produce, ranching, farming, mining. What can we do to maybe give the state engineer another management tool so that we don't have this severe guillotine effect on these rural areas? And so they passed Assembly Bill 419, and it gives the state engineer the ability to identify a critical management area, a groundwater basin, and then the stakeholders, within that CMA have 10 years amongst and between themselves to create a groundwater management plan and present it to the state engineer, and the purpose of the plan is that it will stabilize and allow recovery of the critical management area. Now, if no acceptable GMP is presented by the stakeholders in that area, then the state engineer has no choice but to manage by priority. And so the GMP goals, and you can read those goals quickly, and they're available in that material that's on the website. But basically the goals are to stabilize the aquifer and to ensure the health of the aquifer into the future, as well as to take into consideration the economic well-being of the region itself. Now, it's a little bit of a problem. You can imagine, as was mentioned earlier and as other speakers have mentioned, this, as Mark Twain has said, whiskey's for drinking and water's for fighting. So here we have a situation where people's livelihoods are at stake. And when you try to get them together and say, okay, we don't have enough water for everybody, so someone's going to have to take, forgive me, the short end of the straw. And that becomes very concerning when you look, I've been on this land for 4 generations or 5 generations. And I've raised my family here, and I want my family to continue here. That's going to be tough. And so, as Jake Tibbetts was telling me, Sam, we really floundered here. We really, how can we do this? Should we get a facilitator? We don't have necessarily the money. Should we go the route of a general improvement district? But they became bogged down in inconsequentials, and everyone had a plan. Now, and this is where Professor Young will start off in a moment. They went from flounder to focus. Now, the reason that they were able to do that in this case, and Diamond Valley, as I say, is unique because it geographically and geologically, it is isolated, and it's a groundwater situation. And so we looked at this, and I was familiar with what had been done in Australia and other places. And so I went to the state engineer and said, there's different ways to this. Poor Jake and the people in Eureka County, they're having a difficult time. Would you mind if we went to them and presented to them perhaps another option or alternative for them to follow? He said, Sam, absolutely, go for it. And so we met with them, and we came up with identifying what the issue is. And you have to separate out all of the emotions, you have to separate out all of these things and focus on the water. And certainly in this case, the quote-unquote Australian model is outside the box. And it requires shared sacrifice, but shared benefit as well. And it's an opportunity for increasing the value of that pie, whatever that pie might be. And so, forgive me, Eureka, they adopted a plan that is adapting, but not adopting the Australian model. And that's the beauty of this particular model, is that a locale, or whatever the situation may be, can take those principles and adapt them to the local concerns and local situations. And it's and one of the beauties of it is it's based on an open, transparent formula. And as Jake said, he said, and he held up his cell phone. He said, I love this because we can run this off an Excel spreadsheet. He said, that was one of the beauties of this. And so what it does, and again, we'll go through this very quickly, and it's in the materials for the conference, but it sets up a groundwater share system and a share registry. And that's the heart of that system is that the water, you can see the total groundwater volume, and they use a priority factor, and that comes out with the total groundwater shares. And again, this gives a little more explanation, and Mike, Professor Young, will go into that, and it's available in your material. And this tells that the state engineer who is going to be managing this plan will continue setting up these various aspects of it. So the funding of the plan, and we have different ways to fund it, but it's going to start out at $1 per acre foot. And that will allow the hiring of a water manager. It will allow flexibility within the coverage of the GMP for rodent control, weed control, perhaps buying water rights, perhaps taking ground out of production and so on. And then from those shares, you go to allocations. Again, Professor Young is going to talk about that. And then from shares to allocations to groundwater accounts. And this is what it looks out right now. So to go quickly through these, you have your benchmark groundwater pumping. And that was the 76,000 acre feet that they pumped in 2017. So that's what they're going to use. And the attraction to the state engineer of this is that through this plan, it's going to bring the basin back into a balance within, and depending on how they decide to go, within either 35 years or 22 years. Now you say, well, that's a long time. But again, we're talking that this problem took over 60 years to come about. And also, we're trying to preserve the economic vitality and sustainability of not only the aquifer, but also the community that surrounds it. And so you can see how this takes place, so that in year 35, in the long term, we're down around the sustainable, their perennial yield of the basin. And in a shorter time, the 22 years, we're down around that sustainable yield as well. And this is how it goes. Now, and I know that there are attorneys here, and certainly this would not apply to, could not apply to any of you here. But one of the attractions of this plan, as was enunciated, told me, was that, Sam, one of the big pluses to this plan is the legal aspect of it. And with apologies to Gold Hat and the treasurer of the Sierra Madre, liars, we don't need no liars. We ain't got no liars. We don't need no liars. We don't have to show you no stinking liars. So that is one of the pluses to this. Now I'm going to turn the time over to Professor Young, and as Doug said, gee, how did someone from the West meet this individual from Australia? And we had agricultural interest in Australia at one time, and we were familiar with the situation that occurred in Australia with that horrendous drought that they went through and all that was done. And a colleague came to me and he said, Sam, we've got some problems here in the West, and I want you, we don't know how to solve them, but I want you to meet this guy. And I say, he's got some really good answers, and they've been through this before. And I said, hey, that's great. Who is he? And my colleague said, well, first off, I got to tell you something. He's from Australia. And I said, what? He's where? He's from Australia. I said, I can't. Well, he's from where? He said, okay. He says, he's from Australia. And I said, oh, no. That means, yeah, he's an Australian. But don't worry about it. So far, he hasn't shown himself to be physically dangerous. And I said, well, what good is that going to do? I mean, they don't even speak English in Australia. How are we going to work that? Well, it's worked out great. And you can see from his resume that Professor Young not only played a major part in the development of the Australian model adopted by the nation of Australia, but he has been called upon by governments and private and public entities worldwide, in Asia, Africa, Latin America, to deal with these kinds of public policy challenges dealing with water. And so I'm just very pleased and proud to have Professor Young able to be with us. And here he is, the Crocodile Dundee of international water policy, the water thunder from down under, Professor Mike Young.
Thank you, Sam, and thank you, Michael, also for the chance to be here. Michael Hanneman found the funds to fly me over here, so thank you very, very much. I know we're short of time, so Doug said that this is a new system. The system it copies is essentially 3,000 years old. It was first worked out in the Arabs in the desert, and they decided and realised they had to live with water scarcity and varying supplies, and they got it right 3,000 years ago. Australia's second Prime Minister, before he was Prime Minister in the 1890s, came to America and came back and said, do not set up a prior right system or a seniority system like America did. Do something like the Mexicans did, which is treating all people equal. And that was a very important insight. And it enabled Australia, I think, to discover what we've discovered. Time's short, so I want to show you first the slide that I used when I first spoke to the people in the Diamond Valley. I went down and sat in the back of a meeting like this where they were going through the processes, talking about actually values with facilitators, and I nervously said, I'm here from Australia and I'm trying to understand. And the facilitator said straight away, come up and tell us what you do. I hadn't even prepared any talk, but I had this slide. And there's a lesson out of this, which is if you're going to change water use, you need to find a narrative that farmers understand. In the Diamond Valley, the value of farms was going down. When you walked down the main street, all the shops were falling to bits. They hadn't been painted for a long time. People stumbled around. They had lost their confidence and their pride. They knew they were in financial strife. I put up this slide and said, I could remember when I went to Kerrang, a town in Victoria, which was like Eureka. After we started the reform process and we went back and said, rather than taking the existing rights system and we'll bring in some fallowing programs and we'll do this and we'll do that and we'll try and establish a market, we'll actually design a system from first principles that would work. Forget about what you've got, it doesn't work. Build a system that's designed to work well and which you're confident and can be proud and say, this is the best in the world. When we did this in Australia, an interesting thing happened. The value of water rights, as shown by this graph, went up on average 20% a year. If you don't know what that means, every 5 years, that means your water rights become twice as valuable. Within 10 years, your water rights are worth 4 times what they're worth today. And then I said, do you want me to leave? Or do you want to stay and listen and talk about building a system that will make you prosperous, dealing with a scarce water resource? They abandoned the agenda and spent the rest of the day working with me and the facilitator there, and by the end of the day we had a system. It's actually not rocket science. And it was a system they could fund themselves. They didn't need people from outside. And the critical part in this was Jake Tibbers, who's a local young lad, slightly more than a lad now, but a young man who had the ability to lead people and put them through and talk about difficult decisions and build consensus. In essence, there's some choices that are around. I need to be quick, but you can do what we currently are now doing in California. And yesterday I was in Harnford, sitting down again with local people, taking them through the same sorts of exercises. You can have no limit, and you go for it, and the aquifer goes down. As we've heard around the world, this is what's happening. There's some exceptions. You can put embargo on new wells. You can do what's happening in India. What they do is they now switch off the power supply for days at a time and just stop everybody pumping. Surprise, it works. But it's awful if you're trying to grow a crop. You can put limits on total areas, and you have fallowing schemes. You pay people not to farm. I would love somebody to pay me not to be a professor, and I still get my salary. As an economy, you can't afford to do that. It makes your nation poorer. I can see people nodding. It makes your nation poorer. Why do you design schemes that make you poorer rather than wealthier? So you go on through, you can have standard crop area systems, or you can go to the state of the art and realise that water supplies vary, and you vary the amount of water that can be used year by year, and you build an economy that uses as much water as it can without causing harm. If you go to that next stage, you need a totally different plan. There are two reports that I keep on going back to, which build on it. And the title to this first report, the blue one, is wrong. It talks about water rights. When I wrote this, I forgot an important lesson that came out of the Australian water reform experience. In about 2001, there were about 10 people in the room involved in the water reform. Everybody got together and agreed to do one thing: to redefine all the terms that are being used and never use the word water right. Because when you talk about rights and you're talking about the new system and your new right and your old right, and we're going to have a new condition on this, nobody can understand what you're talking about. So we said the new system will be about entitlements and about shares and about allocations. And so when people are in the room, they're talking about the new and with the old. And these sorts of insights are very, very important. It's about communication. Words like governance frighten farmers. I've found and learnt the hard way when I'm now working in the Central Valley. If I go and talk to farmers about governance arrangements, they think, oh, that's the government. We hate the government. They've designed this system that doesn't work. They don't like it. They don't trust it. So don't use the word. But what you do need is an approved plan, something which gives you a new way to manage the water rights that are there. So what's happening now, I think, which is state of the art in California through this Sigma legislation, is they're going to bring in a new regulation on top. The regulation, if you follow the plan that I've been working on with people, is very simple. If you want to use water, you have to have a water account that has some water in it. And if your water account doesn't have water in it, you're not allowed to pump. And you're in breach of a regulation of the state. It's like once upon a time you could drive in this state, you could drive a car without a driver's license. A new regulation is introduced, you need to have a driver's license. You can introduce in a system a new regulation without redefining all the water rights that simply says you have to have a water account that's got some water in it. Like you have a bank account that has some money in it. If I want to spend money, I have to get the money out of an ATM, and there has to be some water in it. Very simple concept. And that's the fundamental building block of building a new system. Without going in and redefining all the rights, you can leave all the rights underneath. And you do that by also setting up a governance structure. You need somebody who's going to decide how much water is going to be available and how we're going to put it into all the water accounts, which is what the Diamond Valley's agreed to do. And to do that, they have a management board. That board has to be trusted and has to be respected. It needs people like Jake Tibbetts who know how to walk into groups of angry people, calm them down, and talk through the reality. And then next to that, you need to think about how you're going to share out the scarce water resource. As all of you know who are involved in companies, if you're going to share things out, you're going to have a sharing system, and you have to allocate shares. And there's a golden rule with shares. If somebody wants more water or more shares, someone else has to have less. We've all tried cutting cakes. And so why don't you set up a sharing system that says you have a proportion of what's available and nothing more than that? You cannot guarantee volumes unless you know how to make it rain. And in most of this world, you cannot guarantee that. So the state of the art is to have a sharing system. First done by the Arabs 3,000 years ago. Villages sitting there with the variable flows worked out how to build sharing systems. They also worked out very early on you needed to have an accounting system so that people could track who was allowed to take what water at what time. The state of the art in accounts is to have something like a bank account. At the start of a season, The water that's available to you is credited to your account. As you use it, it's debited. Rather than talk about water trading, if you have a credible system that's trusted and is bankable, people will log into their water account and transfer the water from their account to somebody else. You don't have to put a lot of effort into working out how we're going to do the legal stuff. If you design a system that makes it simple and is credible and is fungible in academic terms, it works. So give everybody a water account. And then to make it all enforceable, you have a simple permitting rule that says if you're going to take water out of a well, you have to have some water in your permit or in your account that's linked to that well. And it's up to you to get water into that account. It's very simple. And in the time I've explained to you now, the Diamond Valley people stopped and I said, "Stop talking, Professor Young." And I said, "Why?" Because when the farmer said, "Stop talking," he said, "I want to ask everybody a question. Does this make sense?" And he said, "If it does, put your hand up." And everybody put their hand up. Simple, it's credible, it faces the reality the resource is scarce. So you issue shares, have an accounting system, which they all know how it works, debits and credits and balance. You have a permit and have a simple system that's enforceable. And then we sat down and said, now how do we make this as valuable to this community as we possibly can? What's the detail around this in terms of setting up all these things? Have a central register, state of the art in the world. You do not have paper-based water rights. Everybody knows that the state of the art is to have what's called a Torrens title registration system for the lawyers. You have a central register, and the only way you can own a share is if your name is in the register. Full stop. Why would you have title insurance? Why would you have title insurance? Why would there ever be uncertainty over who owns what? Doesn't make sense. So build a system that makes sense. Have a central register that's guaranteed and has integrity. This is basic, but it's not what you find in America. Same with having a permit system. It has to be linked and it has to have the credibility and it has to be enforceable. If you go on through the structures around this, and there's a lot of elegant theory in it, there are people who got Nobel Prizes on why you keep transaction costs low. Coase did that. There's actually Tinbergen who said you need to have a separate instrument for each objective you're trying to apply. And that's important. So rather than having one license that does everything, unbundle it, separate out the components, which is why in really sophisticated sharing systems you have shares, you have accounts, you have permits, and there's more detail around that. But by having separate instruments, you get control and building it all together. I could spend a lot of time going through the detail that comes out of doing this, but if you go through and talk about with the community, maximising value, maximising benefit, and making sure particularly that the value of the farm assets goes up, not down, and you start explaining to people that if allocations per share goes down, what happens to the value of shares? They go up. We all know scarce things have value. So you build in compensation. You point out to them, as we discovered in Australia, that if you make the shares mortgageable, then banks will lend money actually against that asset. If you have a central register, you can register a mortgage for about $100. And once you have these systems running well, as we now have in Australia, a farmer can go into their bank manager and say, look, I've got $500,000 worth of water shares. Can I borrow 300,000? And the bank will say, yes, sure, sign here. And as you're walking out the door, he'll say, hey, what do you want it for? Because the shares are as good as money. Because the bank manager knows at the end of the year, if you can't repay the loan, he'll ring up you and say, Sam, you haven't paid. Do you want us to put you through bankruptcy proceedings and all your neighbours and all your friends are going to know? Or are you going to sell some shares tomorrow? Sam will say, gee, I'll sell some shares tomorrow. I don't want everybody to know I'm in financial strife. But suddenly you have a very fungible liquid asset. And when you do this, the community can borrow money quickly, can restructure what it does. It doesn't have to go off begging to politicians for a fallowing scheme and the money to pay you not to be a farmer when you're a farmer. And if you have a water account, you get to the stage very quickly, as we have in Australia now. When rain comes through, people switch off all their irrigation and don't irrigate, and the price of water, the water allocations, goes down. So you get a lot of innovation very, very quickly. And then you find that people start leasing farms, young people in their 20s and 30s, they lease the farm, they buy the water as they need, and they don't even own anything, and they run the whole system. And you get totally different crops being grown, totally different systems occurring, and the shops start getting painted again, and you're back in business. Keeping it simple and affordable is critically important. When you have to have thousands of lawyers involved, it gets harder. In the Central Valley where I'm working now, we're facing exactly the same problem. And the question is, how do you start these systems up? And this builds on and extends from the experience in the Diamond Valley. You can imagine there's got to be what's now being talked about as a glide path. Reductions have to be cut down through time. We've agreed in the areas I'm working in California that there's critically, keeping it simple, in each area there will be 3 community decisions taken around an average depth which you're going to, in each part of the aquifer system you're going to manage towards, which is what all of the people here have really been talking about. Choose your average and work out how you're going to get to it. Then set a preferred minimum depth, the depth at which you start saying this is as low as we should ever go, and then an absolute depth and declare it. In the systems we're trying to design now in California, the rule is when you get to an absolute depth, the absolute minimum, there is a legal requirement which will be approved by the state that allocations per share go to 0. Once you get to the preferred minimum, every year allocations per share must drop by 10%. Then you're locking in binding things that drive investment. And you build in there a capacity for people to carry forward and save, as you heard in the last talk, the one before Sam, about people putting water into aquifer and taking it out. If people know these are the rules, then they'll start saving water and carry it forward. I was fascinated in Australia when I first wrote the work that produced the opportunity for people to carry forward surface water, leaving it in the dam and making it available for next year. It was in the middle of the 2006 drought when allocations across the board were at 10%. And we'd forgotten about the environment. We were desperate as a nation for water. I went back to the government and said, by not allowing people to save water in the middle of the drought, you're making the drought next year worse, and probably even making this drought worse. They introduced a change and said to the farmers, you're allowed to change, save water and carry it forward to next year. Do you know what happened to the water market? The value of water the next day after they made the announcement doubled, because all the farmers knew there was so little water around. The greatest risk was going to be a drought next year. So they made the drought worse because they wanted to manage the risk. They knew that the government was making a horrible mistake. Building in the flexibility for them to plan enabled them to do that. If you lock in a rule that says you can only use water when it's been allocated to you, people will start saving. And then you'll start coming back up to that elusive thing that you can't get the recovery. The Diamond Valley people get that. In the first 2 years, you lock in and you make a transition which is short, slow. You have a basin authority that might even bring in some water, do all sorts of things. You might discover you had the hydrology wrong. So you build in mechanisms to deal with that. I don't have time to go into the real detail around it. But putting all this together is not rocket science. It's simple to explain. And when you explain it like this, farmers sign off on it. and it makes a huge difference. Keeping it simple, I've already talked about this, so I can go right through it. But the next bit is, how do you allocate shares? One of the mistakes that's often made, and we learnt this the hard way in Australia, is to allocate shares in an entire aquifer or an entire river. The smarter ways to do it is start by allocating shares zone by zone. If your hydrologists say the area right next to a river has different hydrology to areas further away, and see you're nodding, or you told us in your 101, thank you, it was very good. If you're next to a river, you have a separate zone. If you allocate shares in that, then gradually you can start assembling more and more shares together and amalgamating. But start with lots of little zones and have a rule that you cannot transfer shares out of that zone. You can transfer volumes of water or allocations out at an exchange rate. The work that I've been doing here, I've been paid in US dollars. I need the money in Australia. I take the exchange rate risk. And people keep on changing the exchange rate every day. I know that's the risk I take, and guess what? It's become very predictable. It goes around, it's 0.7 at the moment, it'll go up to about 7.1, 7.2, might go down to 6.8. I hope it does, I'll make some more money. But that's, if you do it like that, then every transaction that's done is of the sum of $10,000 or $15,000. When the costs are at that level, because you're trading allocations, not trading shares, the lawyers don't waste their time getting involved because there's not enough skin in it for them. So the transaction system starts to have credibility, and as Jake said, you get the lawyers out of it. The community runs a system that's designed to work and which is truly adaptive. And you have a board that can change the exchange rate and change it yearly, and you learn. And if somebody wants to trade water 5 zones away, you say, gee, that might be hard, but we can do it bit by bit. And a mock-up water account, this is not rocket science to you, just looks like your bank account. It's all there and recorded very simply. These systems exist. Why don't we have them for water? And wouldn't it be nice if you're a water manager and you could add up everybody's water account and tell all the community that there are this many acre feet of water still unused? And people could look it up. Actually share information so that managers can manage. We don't do that. Why? It's basic, but we don't do this in so many water systems. And you set up trading rules that look like this, from zone 1 to zone 2. Look up and you notice there are lots of zeros there. Nobody really thinks it's possible to go from zone 1 to zone 3. We might employ a hydrologist to see what we do. And importantly, as well as that, you put a maximum volume on the amount of water that's allowed to be traded from one zone to another. And over time, you can increase that, but it's done adaptively and cautiously, and you learn what's going on, and you monitor and see and discover how your aquifer works. The communities I know that they don't really know their aquifer. And when they talk to their consultants who are trying to model what's going on, the consultants scare them because they say they think it's like this and they think it's like that and they think water goes from here to here, but they're not quite sure. And all of the court cases around trading at the moment and shares and leasing and all this stuff which is so expensive all reflect the fact that there is not a commitment to building a truly adaptive system. The world worked out how to have exchange rates and how to move money around years ago. If I want to transfer some US dollars to Australia, there's no way a lawyer can get involved to stop that transaction occurring. Why can't we have systems in water that are credible? And I think this is very important. And at the same time, you use permits to deal with drawdown, back to actually Water 101. If you have permits, you deal with neighbourhood effects. This is not rocket science. But it's separated out from the shares and the ownership of the shares and the investment of the farm. It's separated out from the management of the water that's available this year and allocated zone by zone. It's all adaptive. And so you have a separate instrument for managing the local effects. And if, for example, a plume comes through which is contaminated, you don't stop allocating the farmer the water. He still gets a water account, he's just not allowed to take it out of this well. compensated automatically then, rather than going and say, oh, we really should shut you down and not let you pump from this well. Sorry, you can't take your water this year. You actually still give them water and say you can use it somewhere else. And it's amazing when you build these systems, how quickly surface water users start thinking about dropping water into groundwater, and how you start realizing, if you get all the proper recharge calculations occurring, that there's linkages over long distances between farms and totally different ways to manage crops and where you manage water. And this all comes from building systems that are designed to work, and putting it all together. And once again, another important characteristic in this is, if you have a permit, you have a whole set of regional rules that are not attached to the permit, so they can be adapted for the whole reason by changing the plan or changing a website and sending everybody a notification that the new condition is X. That's what a truly adaptive system does, and you build systems that enable that to happen. You don't have everything on a permit and people can't find the right permit, it's lost, where is it? You design it so it's truly adaptive, as you do with your own life and your own business. You deal also with domestic users. One of the things we're now working on in the Central Valley and in the communities who are doing this is they're saying, yes, there is a human right to water. So for domestic water, we will get the city or the county, on behalf of all the small domestic users, to hold shares. They're going to be part of the sharing system. So we're going to make sure, if the county allows people to come and live in the county, that they are accountable for working out who's going to give up a share. We don't build systems in that let towns grow and farmers suffer. It has to be planned for. And we understand that. They understand that, and they see the sense of it. And it's really interesting if you think, in many will have you heard what happened in Porterville. And it's the Porterville engineer, and Porterville ran out of water a few years ago and had to truck it in. It's Mike Reed, the Porterville engineer, who wants this, because he wants a system which is credible and he can trust. So he can go back to his board, his supervisors, and say, we need to get some more shares so we can have some more people in this town. Or we have to ban watering lawns, but we've got to solve this problem. And there's a legal obligation to do it. Issuing shares is the hardest part about all of this, but I just want to quickly put up that there are many steps involved in doing this. This is where the lawyers have a field day. But you can fight about this forever, and the Diamond Valley people have been through this, and it was the thing that took longest. The basics of the plan, I wrote a rough draft and said, here it is. They worked through everything except the share allocation system very quickly. There was a lot of angst and agony, but ultimately they worked out they were better off biting the bullet and coming up with a formula and getting on with using water and creating a prosperous community than going on fighting about it. I haven't got time to go in, but the state of the art in this, and there's a lot of experience in this in the United States. Experience. And it's in your fisheries industries. Your fishery systems all through the United States have set up sharing systems, and they allocate fishing quotas season by season. They've done all of this. It's not hard. And you get facilitators who are trained to do it, and they run the process, and it's all over. There's a lot of experience, but the water industry tends to look at the water industry rather than look at other things, actually experience elsewhere. So I put all this together to wrap up, and I'm sorry this has taken a bit longer, Doug, but I think it's important. If you take some of the software that's around and take the plan that I've produced and you look at it, this is the word map that comes out, which is about having a plan. The plan is about decision-making rules. It's not what tends to happen, which is lots of documentation and arguments over models and everything. At the end of the day, you realise judgments have to be made. What you need is rules that are institutional rules that say this is how shares are going to be defined, how you find out who has what share, and a system which is believed and trusted and which is bankable, and which the community has an interest in ensuring works. And they're more committed to making sure the system works and going off to the court and destroying its credibility. And when you build an institutional structure that truly recognises that groundwater is scarce, that shares it out in a way that says if anybody gets a larger share, someone gets a smaller share, that it manages use meter by or drop by drop as it occurs, and is enforced by everybody, you have a system which you can then say is truly state of the art and which you can expect to work. And that's what the word robust means. Thank you very much.
All right, that was fantastic. The only downside is we're way off schedule, but that was fantastic. So we're not going to do the questions now. Mike is going to be on the final panel at the end of the conference tomorrow, which is a question and answer sort of panel. So you'll have plenty of time to ask him questions then. Sam can't stay that late, but will be around for a while. So you should corner him with your questions, maybe at lunch, for example. So take advantage of their expertise while they're here. We're going to go lunch. We're off schedule. We will reconvene, let's say at 15 after, so 45 minutes from now. That'll be plenty of time for lunch. It's easy. It's just it's basically the other side of the ceiling here. Just one flight straight up will be